entire j omega axis in the S plane will be into the circle about the unity. That means left half of the plane is mapping into the inside about the circuit by the trapezoid method. That means if you have the S equal to j omega 1, the point here, easily can transfer to the Z E j omega ts in the origin in the circle about the 1. That means Z, if you remember, E equal to S ts. Substitute the S by the j omega, you can find the Z1. The continuous time system is designed such that for the certain frequency omega 1, the frequency is HSF1, that means you put the S equal to j omega 1. And I know that Z equal to E STS, so the Z1 will be E j omega 1 TS. This is the testing transformation. If you remember, SF1 will be j omega 1 in the continuous time with TS Z1. That means I will go to the change to the Z domain. I substitute all of the Z1 by E S TS, and S equal to j omega 1 will become 2 TS E j omega 1 ts minus 1 ts E j omega 1 ts plus 1. That means omega prime 1 in the continuous time and omega 1 in the discrete time. From the S j omega prime 1, that means the j omega, and with testing rules I will substitute by the j omega 1. Okay, if you substitute here and extend these equations, you will reach to the here, and E j omega 1 ts minus E minus j omega 1 ts, if you remember, become the 2 cosinus omega 1 ts, and here become 2j sinus omega 1 ts. Okay, omega prime 1 is equal to 2 ts, 2 minus 2 cosinus omega 1 ts, and with the sinus omega 1 ts I extended by here, and the cosinus omega ts, if you remember, I extended here. I substitute both of them here. I will find the 2j 2s tangent the omega 1 ts divided by 2. Here become j omega prime 1 will be 2j ts tangent omega 1 ts. That means I can find said the omega prime 1 is equal to 2 ts tangent omega 1 ts divided by 2. If you make this one, the name is I put the omega, and this one I put the omega ts, I put the omega. I can find the relationship between this. That means omega for me will become 2 inverse tangent minus 1 omega t divided by 2. Or I can say the omega in the discrete time is equal to 2pf, the frequency, and the sample frequency, or I can write the omega t, and it's normal in the discrete time that omega will be in the continuous time multiplied by the t. This is the linearization about the nonlinear of here. This is the nonlinear and this is the linear. And omega, I can write the name is omega 1, and this one is the name is omega, and this one I put the name is omega 1, and this one is omega. And if you draw the system, we become the omega 1 versus about the omega prime 1. This is a continuous time, this is a discrete time. You can find the inverse tangent about this figure. And if the linear part and I find omega prime is equal to omega 1 t, sorry, this one reverse, that the omega 1 equal to omega prime t, the linearization will be something like this. The name of this is a pre-wrapping of the system. Now, since Tz, that means in the z domain, is equal to Hz, such as S in the put the trapezoid, for the z equal to z1, Htz1 is equal to Hs, S prime, we put the t equal to z1. That means Htz1 equal to Htz1 is substitute the S by the trapezoid of my system. This is a testing rules that I find another method to change the S domain to the Z domain by substitute of the S by this formula J2Ts tangent omega 1 Ts divided by 2, and is normal. This is not equal to Hj omega 1 because the linear part is possible, but because we put the non-linear is a, if you see in the previous slide, it was the omega 1, here is equal to tangent minus of omega ts divided by 2. Again, this one I put the omega prime 1, sorry, here I put the omega prime 1. Okay, this will not be equal together, but you can change to the discrete time. And when we become equal together, if omega ts1 is a very smaller than 1, then Htsz is equal to Hj omega 1, because we become completely will be linear. How can I use the testing rules with pre-wrapping? Write the desired filter characteristic in the form of the Hs omega 1, omega in this discrete time, where the S omega 1 is a pre-wrapping frequency. Apply the following substitutions. Hz in the discrete time become Hs omega 1, such as you put the S by the testing rule. Now we give the one example will be clear. Find the discrete equivalent of the Hs s plus 1 s2 plus s plus 1. If you remember, we find the z minus 1 ts z, this one is a backward, another one we put z minus 1 ts, and another one we put the z minus 1 z plus 1 ts, and here is a dominator 2. And another method is the name is a trapezoid with the pre-wrapping frequency omega 1 equal to 1. For this, I know the omega is a 1, I put the Hs1 become S1 plus 1, S1 power 2 plus S1 plus 2. This is the step 1. Step 2, you substitute S by the formula of the trapezoid. I find the tangent, I substitute here, and I find the H trapezoid based on the Z domain. I find the formula about the in the Z domain. This is another method to discretize my system. Now you saw the S equal to what? You substitute the S by Z minus 1 Ts multiplied by Z. And the integration about this, 1 upon about s, is normal, will be what? Will be ts z and z minus 1. This is for the backward. In the forward, if you remember, will be z minus 1 ts, and the normal, if you find the 1s, will be ts upon about z minus 1, and the trapezoid will be the same. The name is a approximation of the integrations. And the similar approximation of the derivative here will be the same, but as I wrote by the 1 minus z minus 1 will be the same. In the backward will be z minus 1 ts multiplied by z, or I can rewrite this one ts by 1 minus z minus 1. Both of them will be same. The derivation is s, we saw together, and the integration will be reverse. Now we go to another method. The name is a zero-pole matching. Until here you learn 4 methods to change the HS to HZ.